Hello, dear students. This is Mr. Muhammed Azeez, and there it comes a new lesson. We begin with question 24 that we stopped in the previous lesson at question 24. Now, in this lesson, let's solve question 24. So, let's take to the notebook. So, write this here. Question 24, we have a function fx equal to sine x multiplied by cosine x. And we need to find critical value intervals on which the function is increasing or decreasing, and we need to find first derivative test, use first derivative test to find local extrema, means maximum and minimum. First of all, this function is very important. If you know its graph, then you will have no problem. You can find everything graphically. But here I'm going to find everything algebraically, and then I'm going to show you how important graph is. So if you know the graph of this function, sine x multiplied by cosine x, you can find everything required for this question easily within a minute. Let's begin. To find critical value, we begin with derivative. So f prime x is equal to first times derivative second, sine x multiplied by negative sine x, that is derivative of cosine, plus second, which is cosine x, multiplied by derivative of first, which is also cosine x. Sine times negative sine is negative sine squared x plus cosine squared x. Here in this step, a lot of students confuse. They think sine squared plus cosine squared is 1, which indeed is correct, but there is a negative. Because of this negative, this result will not be 1 or negative 1. No, it's none of them. Now we have the first derivative. To solve this, we need to set first derivative to be equal to 0. And I'm going to write the negative term in the second place. So cosine squared x minus sine squared x equal to 0. To solve any trigonometric equation, we need to have only one type of trigonometric. Then we can solve. Here we have cosine and sine. That is not solvable. Then what should we do? For situations like this, divide everything by cosine. Why I do this? Because sine over cosine will be 10, and cosine over cosine will be 1, which is good. Over cosine squared x equal to 0. 0 divided cosine is still 0. Now let's continue. This will be 1 minus sine over cosine is 10. Each of sine and cosine are squared, so the tan is squared equal to 0. Now I need to solve this. Tan is negative, so let's send tan to the other side to be positive, which is easier to deal with. 1 is equal to tan squared x. To remove power 2, we need to add square root to both sides. The number side will get positive negative. Now I have tan x equal to positive negative 1, or I can write it as two equations. Tan x equal to 1 once, and it has two possible answers from 0 to 2 pi, or tan x is equal to negative 1. That one as well has two possible answers. Let's do them. Now, in order to find x, I have the result, I have tan. I can use calculator. Press shift tan 1. Shift tan. Tan inverse. Make sure you see the negative 1 on calculator, then trust the result. Tan inverse of 1 is 45. So x is equal to 45. But that's not the only possible answer. There's another one. X equal to 45 plus 180. Let's check. 45 plus 180 is equal to 225. How can I accept this answer? 225. Is this accepted? If this x is satisfying this equation, then it's okay, it will be accepted. If this x is not satisfying this equation, then this x will be rejected. So again, easily you can just use calculator. Tan 225. If I got 1, I'll accept 225. If I got something else, then I will reject 225. Then I'll go with 180 minus 45. Then we'll see. That's 1. Cool. So 225 is accepted. 45 is another possible answer. Now let's go to the other side. Tan x equal to negative 1. So shift tan negative 1. Close bracket, result, negative 45. Negative 45 is not in this interval, but if I add 180 to it, plus 180, if the plus 180 didn't work, I will try minus 180. Plus 360 minus 360. 135. Let's check 135. Let's try to not miss. X equal to 135. Now let's test this out. I'm going to write 135 in place of this x, and I'm expecting the answer to be negative 1. If not, reject. Tan 135. Result, negative 1. Boom, that's correct. Another possible answer is 135 plus 180. 135 plus 180 is 315. X equal to 315. Now again, my test, tan 315 is equal to negative 1. That's also correct. Now I have 4 critical values. So I make a table for all of these 4 values because the graph is 5 pieces, all increasing, decreasing respectively. Okay. Then we have a place for x, place for f prime, and a place for f. X. F prime to be positive or negative, and f to be increasing or decreasing. The beginning of the interval is 0. The next x value is 45. More than 45 is 135. That's in order, and it has to be in order. 225 and 315. All right. Now let's try. Choose a number between 0 and 45. Let's say 40. Put 40 in place of x in the first derivative here. Or we can use this one or this one. They are all the first derivative. I want to use this one because I will input x once. That's the best. Okay. Tan. Then how can we write power 2 in calculator? We use brackets. Tan 45, close bracket, not 45, 40 I said, for testing. This should be a number between 0 and 45. 40, power 2, that's equal to 0.70. Then what I have 1 minus tan squared, which is 0.70. This result is positive. Positive means this interval is increasing. Then similarly, if you choose a number between 45 and 135, plug it into tan squared, here, let's say 100. The result is 32. 1 minus 32 is negative, decreasing. A number between these two, let's say 200. It's 0.13. 1 minus 0.13 will be positive, increasing, negative, decreasing. And the end of the interval is 360. We have to write that as well. And we need to choose a number between these two. The number makes the first derivative positive, that's increasing. So intervals of increasing are from 0 to 45, from 135 to 225, and from 315 to 360. Intervals of decreasing are from 45, 135, 225, 315. 2 intervals of decreasing, 3 intervals of increasing. We can write any of these numbers in terms of pi. If the multiple choices are in terms of pi, just write the angle, let's say 135, divide by 180. I got 3 over 4. You will see in your calculator 0.75. Then you have a button here, ABC. Press ABC. That will make it fraction. Fractions in your calculator will appear like this, 3 over 4. But anyways, to change any of these angles from degree to radian to write pi, if the multiple choices are in terms of pi, just divide the angle by 180 and then write pi next to the result. So 3 over 4 pi. 3 over 4 pi is 135. If I want to change 315 to radian in terms of pi, just write 315, divide 180. The result will be a fraction, 7 over 4. So the answer will be 7 over 4 pi. See? Now we found everything we needed. Finally, we need to find local extrema, and local extrema means maximum and minimum. This is maximum, 45. Put 45 back into the original function, get the y value, then as point 45 and the result of inputting 45 here together will be a local maximum. 225 the same will be maximum. And how many minimums are there? 2. 135 makes it minimum, and 315 is minimum, and these are maximum. Right, question 24 is complete. By the way, the graph of this function, sine x cosine x, the graph is like this. You need the graph from 0 until 2 pi. See? Maximum, maximum, minimum, minimum. So if you know it graphically, you can easily find increasing, increasing, decreasing, decreasing. Minimum, minimum, maximum, maximum. All right, question 24 is complete. Okay, these questions are pretty fine. Let's do this Wizadi question of 2023-2024. The question says find the critical value of the function fx equal to x e to x. All right, in order to find critical value, we need to find derivative first. So f prime x is equal to, that is multiplication. So first multiply by derivative of second. Derivative of second is 2e to x plus second e to x multiply by derivative of first, which is 1, that stays the same. Now derivative equal to 0, x 2x e to x plus e to x equal to 0. Now derivative equal to 0, I can solve or I can use these x's. Which of these x's make the result 0? You know these two e2x is common factor. Let's take e2x as common factor. See what's remaining. What's remaining here is 2x plus nothing remains here means 1 equal to 0. E power x is never 0. What's supposed to be 0 is 2x plus 1. So 2x plus 1 is equal to 0. 2x equal to negative 1. X equal to negative 1 over 2. That makes B the right choice. Use the given graph on the right to find the result of 4f of 3 minus 3f prime 3. All right. Look at the graph. We have a function and a tangent line. So we use the tangent line to find derivative. Why? Because we can get slope from tangent line. So from tangent line, we can get slope. And slope means derivative. Where? At x equal to 3. Okay. And f of 3, we can get it from the curve. F of 3 is equal to 2. Now, 4, f of 3 is 2. That's 2. 4 times 2 minus 3 times. Let's find the slope. Here on this straight line, we can select 2 points, 2 good points. This is a good one. 3, 2. And this one, this point is 4, 0. Check. 3 in x, 2 in y. Cool. 4 in x, 0 in y. That's good. Slope is equal to y2 minus y1, 2 minus 0 over x2 minus x1, 3 minus 4. The answer is 2 over negative 1. That is negative 2. Checking the information, this line is decreasing from left to right. Its slope is negative. That's logical. That is correct. Then this negative 2 is slope, which is f prime 3. Negative 2 goes there. 4 times 2 is 8. Minus minus will be plus 6. Answer 14. C is the right answer. Find the critical values of the function fx equal to x squared over x plus 1. Okay. To find critical value, we just need to find derivative first. Let's find the derivative. Derivative f prime x is equal to fraction x plus 1 all squared, denominator x plus 1, multiply by 2x minus x squared, multiply by derivative of x plus 1 is 1. No need to write. Okay, let's simplify. 2x multiplied by x is 2x squared. 2x multiplied by 1 is plus 2x. This is dot means times. Minus x squared over x plus 1 all squared. This simplifies to 2x squared minus x squared is just x squared plus 2x over x plus 1 squared. Now we can take x as common factor. x plus 2 is up while x plus 1 is down. This will be 0 if the numerator is 0. So x equal to 0, x equal to negative 2. And this will be 0 if x is equal to negative 1. Negative 1 makes the derivative undefined. 0 makes the derivative 0. Negative 2 makes the derivative 0. So all the cases of critical value are here. These two numbers make the derivative 0, which are critical, and this x makes the derivative undefined, which is also critical. Then A is the right answer. Bravo, you are too smart. No, life is not that easy, bro. Come back here. This x makes the derivative undefined, but you forgot something. If you remember, I said if a number makes the derivative undefined, we need to check that same number with the original function. If it makes the original function undefined as well, then that is vertical asymptote, and vertical asymptote cannot be critical value. We write it in the table. It will be a border between increasing, decreasing sometimes, most of the times, but it cannot be critical. Then if I put negative 1 here in the original function, I will get 1 over 0, which is undefined. Then x equal to negative 1 is not critical, it is vertical asymptote. That means we have two critical values, 0, negative 2. D is the correct answer. So be careful to not go to course D. Okay, let's keep going. Oh, it's endless. Nah, these are very easy questions. Find maxima, find minima. No, these are easy. Polynomials are easy. Okay, a question from practice book. XEX. That's quite close to the Wizari question I just solved. Ln x over x. Okay, let's solve this. Ln x over x. What should we find? Find the intervals of increasing and decreasing. We need to find intervals of increasing and decreasing. So we begin with derivative. F prime x equal to denominator power 2, denominator times derivative of numerator. Derivative of ln x is 1 over x minus ln x multiplied by derivative of denominator is 1. No need to write. So it is like this. X cancels x. So I have 1 minus ln x over x power 2. What makes the numerator 0? 1 minus ln x equal to 0. Then ln x has to be 1, so 1 minus 1 is 0. Or send ln x to the other side. To be positive, it's easier to deal with positive. 1 is equal to ln x. How can we remove ln? We can raise both sides to power of e. Ln and e cancel out. E power 1 is e equal to x. So this e is a critical value. What makes the denominator 0 is x equal to 0, but 0 causes trouble for the original function as well. That means 0 is the vertical asymptote. Can we have any number less than 0 in this function? As ln is undefined for negative numbers, the answer is no. Ln is also undefined for 0. then this 0 is the beginning of the graph. The negative infinity part is not included at all because it's not in the domain. Then this graph starts from too close to 0, not 0 itself as well. 0 is vertical asymptote. Okay. Then E is a critical value and goes on for positive infinity. Between 0 and E for testing, I'm going to choose 1, put 1 into the derivative. It will be 1 minus ln of 1 over 1 power 2. Ln of 1 is 0. We will get 1 over 1, which is 1. 1 is positive. That means the function between 0 and E is increasing. More than E, let's choose 3. Put 3 into the derivative, and we will get 1 minus ln 3. Result is negative. Since it's negative, the function is decreasing. Denominator is power 2. It's always positive. That's why we don't care about it. Negative is decreasing. So this function is increasing from 0 to e, and it's decreasing from e to positive infinity. Then the maximum happens at e. If we input e here, the result will be ln e over e, which is 1 over e. 1 over e is the y value, and the x value was e, so e and 1 over e is the point where the local maximum occurs. Which of these functions have minimum? There is minimum, there is minimum. This is not differentiable at this point because it's cusp or sharp corner. This is not differentiable because it's discontinuous, but there is a point that is minimum. There is no minimum. There is no minimum, quite smooth. And these are from practice book, no minimum, no minimum. That's open, means discontinuous. There is minimum and there is minimum. Okay. This is the end of this lesson. Section 4.1 is complete successfully, alhamdulillah. Next lesson we will start on chapter 4, section 2, second derivative test. Good luck, everyone. Don't hesitate to ask your questions. Send me your questions on any social media platform or comment it below this video. Anyhow, I will be answering inshallah accordingly. Have a good day.